Hello everyone. To today's video, we are going to talk about Dynamic Host Configuration Protocol, also known as DHCP. To start this video, I want you to imagine this scenario. You just purchased a shiny new computer or another network device. You are brimming with excitement to connect it to your network and dive into using your new computer. But wait, there's a daunting hurdle in your path. And that is you must manually configure the IP address, subnet, default gateway and DNS server yourself. Fear not, for that is where DHCP swoops in like a digital superhero, armed with the power to make your network dream come true by automating this tedious process. In the blink of an eye, DHCP dynamically assigns an IP address, subnet, default gateway and DNS server to your new computer, granting it instant connectivity to your network with the help of the DHCP protocol and a DHCP server on your network. So now prepare yourself to discover what DHCP is and how it works and what it is. So what is DHCP? As mentioned earlier, DHCP is a network protocol that dynamically assigns IP addresses, subnets, default gateways, and DNS servers to your network devices on the network. This automated process eliminates the need for manual configurations of these values on each individual network device on our network. Just imagine the immense time and effort that can be saved by eliminating the need for manual configuration of IP information across multiple network devices. Additionally, by removing the possibility of human error in configuring IP information, the risks associated with misconfigured network devices can be greatly reduced as well. In terms of port usage, DHCP relies on UDP port 67 and 68. Port 68 is designated as the client port, while port 67 serves as the server port. Although these are the standard ports for DHCP, it is technically possible to configure DHCP to use alternative ports. However, it's important to note that using non-standard ports can lead to compatibility issues and may not be supported by all DHCP clients and servers. Now let's turn our attention to look at exactly where is DHCP used and how you can benefit from it. The fascinating aspect of DHCP is that you might already be using it without even realizing it, which will be covered in the next slide with some real-life examples. Real-life examples of DHCP. Now let's talk about where DHCP is used in real life. I have two examples here that I would like to show. I have from my home network and a small business network and an enterprise network. Let's start with the home network and small business network. Usually in a home network and small business network, you have a router/firewall that connects all your multiple devices to the network. Chances are it acts as a DHCP server, automatically assigning IP addresses to your devices. This can be seen up here in my upper right corner, which is said home network, small business network. Enterprise network. In a large-scale network, usually there are dedicated DHCP servers that handle the IP address assignments. Large-scale networks usually have hundreds or even thousands of devices that heavily rely on DHCP for quick IP address efficiency. DHCP servers are often deployed in a redundant load balancing configuration. Later, we will dig down as to why you would have dedicated DHCP servers within a redundant/load balancing configuration on a large-scale network. But firstly, we must cover the DHCP protocol process in the next slide, how that works. Now let's dive deeper into how DHCP protocol works behind the scenes. Understanding the step-by-step process will give you a clearer picture of how DHCP dynamically assigns IP addresses and other network values to our network devices. So let's explore each state in detail. First, DHCP is a client-server protocol that works with these four steps it goes through. We have the DHCP discover, the DHCP offer, the DHCP request, and the DHCP acknowledgement. DHCP discovery. When a device, such as a computer or smartphone, connects to the network, it starts the DHCP process by sending out a broadcast message on the network, which is called a DHCP discover packet. This packet acts as a request for any available DHCP server on the network to provide it with an IP address and other network configuration information. DHCP offer. When an available DHCP server on the network receives the DHCP discover packet, they will respond with a DHCP offer packet. This packet includes an available IP address, subnet, default gateway, and a DNS server. DHCP request. After receiving one or more offer packages, the network device evaluates the options and selects one of the offered IP addresses. To indicate its acceptance, the network device sends a DHCP request to the chosen DHCP server. This packet communicates the device's request for the specific IP address it has selected from the offers received from the DHCP servers. DHCP acknowledgement. The DHCP server or DHCP server receives the DHCP request packet and verifies that the chosen IP address is still available in its pool of addresses. If it is, the DHCP server sends a DHCP acknowledgement packet to the device, confirming the assignment of the IP address and providing the requested network configuration values. I know we have covered a lot so far, and I would like to share a little tip with you, which can give you an easier way to remember the steps of the DHCP protocol that it goes through. To remember the steps involved in the DHCP protocol, you can associate each step with the letters in the name DORA. The D stands for the DHCP discovery, the O is the DHCP offer, the R is the DHCP request, and the A is the DHCP acknowledgement. Additional features of a DHCP server. IP address lease. A DHCP server assigns IP addresses with a lease duration, specifying how long a device can use the assigned IP address. After the lease expires, the device must renew the lease to continue using the IP address. So let's say you have been given an IP address from the DHCP server that you can keep for 2 days. If you do not communicate with the DHCP server within 2 days, that specific address goes back into the pool of addresses that the DHCP server can hand out to others on the network, and means that you'll have to request for a new DHCP address. Renewal and rebinding. As we just talked about, a DHCP server can support lease renewal. This is where a network device extends the lease duration of its IP address before it expires. If a network device fails to renew its IP address, it enters the rebinding phase and requests for a new lease from the DHCP server. DHCP redundant servers. To ensure high availability, organizations can deploy multiple redundant DHCP servers. If one server fails, another takes over, and that minimizes server disruption. DHCP load balancing. In larger networks with heavy DHCP traffic, load balancing distributes the load across multiple DHCP servers. This optimizes performance and prevents bottlenecks. As you can see on this drawing, this is what I just talked about, the things that it benefits in the enterprise network. In conclusion, DHCP is a critical protocol that simplifies network configuration by automating the assignment of IP addresses to our network devices. This allows our network devices to seamlessly communicate within their local area network and access the vast resources of the internet. By understanding the inner workings of DHCP, we can truly appreciate its role in modern-day networks, making our lives easier and more efficient. I hope this video has provided you with valuable insights into DHCP and has given you a better understanding as to what it is and how it works. If you found this video useful, do not forget to like, share and subscribe for more exciting content. And please feel free to leave any comments in the comments section down below. That is about it for now. Have a good day and take care.